Hi folks, today I have a lesson for you on reaction mechanisms. When a reaction mechanism is given, it is trying to tell us how reactants going through elementary steps are converting into products. In this case, they have given us a reaction mechanism which involves two steps. The first step, H2O2 plus I minus ion, forms water and IO3 minus ion, and they have indicated that this is a slow step. That means this is the part that takes the longest in the reaction. The step 2 is considered the fast step, and H2O2 plus IO minus will form H2O2 and I minus. Now, the first question they have asked us is to write the equation's overall reaction. So equation for the overall reaction. So what we need to do is we need to look at the reaction that is given to us, cancel out anything that is common on the left hand side and the right hand side, and whatever is left becomes part of the overall. So, and the equation I have, I see common things on both sides is this IO minus, and so that can cancel out. One is on the reactant side, the other one is on the product side, and I minus there is on both sides as well, so that can be cancelled out, and I believe that is it. So the overall reaction then is 2H2O2, because we have two H2O2s forming 2H2O plus O2, because those are the things that are left over in the two equations. So we just brought them down, arrow kept in the same place. We have two H2O2s forming two H2Os and an O2, and that is the overall reaction equation. Now the second one we have is to write the rate law for this reaction. Now for our class purposes for grade 12 course, what you will find is they are not going to give us the second reaction or the third reaction as the slowest step. They're always going to give us the first one for the slowest step, but that is not a requirement for a reaction. Other steps could be slow steps as well, but for those they will not ask us to write the rate law. So in this case, the rate law, again based on the chemical equation that is given to us, rate is equal to K square bracket H2O2 bracket close to the power of X. Okay, and this is the power of X because based on this overall reaction, the reactant is only H2O2, and in this case the coefficient before the H2O2 cannot be assumed as the exponent for the rate law. Only from the elementary step can you decide what the exponent for the H2O2 is going to be. Okay, so the H2O2's exponent is based on the elementary step, not the overall reaction. If you are deciphering the rate law from the overall reaction, which is what we just did, the exponent is going to be X, and we cannot say if it is 1 or 2 just by looking at the overall reaction, right? But if you are able to consider the reaction mechanism that is given to us, what you would find is in the reactant side, H2O2 was by itself. So H2O2, the coefficient before that was equal to 1. So in this case, X would be equal to 1 if you are looking at the slow step in the reaction mechanism. Okay, so if you were not looking at that, then the X would be written down for the rate law. Now it says what acts as a catalyst in the reaction mechanism. So in the chart we cancelled out 4 things, right? A catalyst is a substance that is used and reproduced. So it's going to be consumed and produced by the end of the reaction. So in the beginning it's going to be consumed, and then at the end it's going to be produced. So if you see this substance here, this is being consumed in this reaction, and at the end it's being produced, and therefore this is a catalyst. So I minus is considered a catalyst. On the other hand, for the next question, they are looking for an intermediate. Now, intermediate is the reverse. It is first produced in the reaction and then it is consumed. And in this case, if you see IO minus is produced first and then it is consumed, and therefore it is also not present in the overall reaction. And this is our intermediate. Right? And so that's how we can look at a reaction mechanism and determine what is the rate law for the reaction, or what is the catalyst, or what substance is acting as a catalyst, and which substance is acting as an intermediate in a chemical reaction. I hope this helped to understand the difference between the catalyst and an intermediate, how to write the rate law, and how to determine the overall reaction equation from the reaction mechanism provided.